Hello everyone, this is Dr.Hira, and in this lecture we are proceeding our discussion about alkyl halides, but our today discussion is about mechanism of halogenation. So previously we have talked about the halogenation of alkanes for the preparation of alkyl halides. We have talked about regioselectivity, that bromine and chlorine have some specific preference for get attached to certain carbons or replacing certain hydrogens, primary, secondary, and tertiary one. So what would be your major product? Now we'll talk about that. What are the sequence of events? So mechanism is basically to give you the detail and explanation of the sequence of events or the steps what the starting material is taking from initial to be in the product form. So for example, if you're traveling from Lahore to London, or you want to travel from uh, any one country to another country. So obviously there could be the plan of your traveling, and this complete itinerary is basically giving you that either you are having what of the connecting flight you taken, what were your road traveling. So that complete information is giving you the whole sequence of events, and how you just travel from one country to another, or from one city to another one. So in the similar way, when the reactions are happening, so they are going through the different steps. So some steps are very fast, and they just have the very shorter time period, but they are happening through some step. This is not the case that we are mixing and they are just instantly coming to in a product form. They take some time. Some reactions happen in seconds, some reactions take even few hours, and some reactions are happening even in days. But uh, even in seconds or the day times, if they are have the span of the reaction of the 24 hour, but they are going through some intermediates, some of the transition states, and then eventually they are converting into the product. So right now in this slide, if you are just you are looking at the reaction where this is the ethane, and we are treating it with the chlorine molecule Cl2, and we have prepared the ethyl chloride, or you can say the 1-chloroethane plus HCl. So we will talk about this particular example, and we will see, we'll take it as a case study, and we will see that what are the different steps by which an alkane is going through the halogenation. And finally, we are having the alkyl halide or haloalkanes as our final product. So this is called the mechanism of halogenation of alkanes, which we are going to talk about. So firstly, we have also discussed about this one, that for happening this halogenation, we need some sort of energy, and that energy could be in the form of heat or in the light. So let's start about the mechanism of halogenation of alkane. So alkanes undergo halogenation by the mechanism which the chemist has termed or named as radical chain mechanism. So as a radical chain mechanism name states, so this involves the production of the radicals, and these radicals are continue to react um, uh, as a chain reaction. They propagate in a chain form, that they keep on going until all of the radicals or the reactive species have consumed, right? So this is called radical chain mechanism. So they have categorized as the radical chain mechanism involve the three main steps, or the three types of steps. So we will discuss individually. The first thing is the chain initiation. So the chain initiation is a step. It means uh, in our daily life, anything, if we have aim, we want to prepare our exam, we want to do our assignment, if we are working on a project. So the very first thing And the very hardest thing is to cross, to deal with your procrastination, to initiate that project or to initiate your work. So that initiation step is basically the energy consuming step. And similarly, this is happening with the chemistry. So that chain initiation requires the energy, and from which source we are providing that energy. If we're talking about the halogenation of the alkanes, so this comes from the thermal. We are providing heat, or we may go for the light. So either we can use the visible light range or the UV light. So they both have that spectrum of the wavelength that which has the equivalent energy that they can easily break the halogen bond and the carbon and hydrogen bond, which has to replace with the halogen one. So the first thing is the chain initiation, that we have to convert the neutral molecule into some of the reactive species that it can initiate that chain reaction. Now, the second step is the chain propagation. So once the reaction has initiated, they are the reactive species which has formed, or specifically the radicals they have formed. So they keep going and they are propagating. So that is called the chain propagation step. Now, the third one is the chain termination. So chain termination step is this one, that the cycles are keep on going. There's a cycle, one cycle, second cycle, and third, and so on. So then all of the reactive species have consumed and they have converted into the neutral molecules, right? And all of the energy has consumed. So now this is the ending point, or this you can say the full stop of that reaction. So that is called the chain termination, that all of the reactive species has consumed. So now there is no more culprit to initiate another neutral molecule into the reactive one. So now this is the ending of the reaction. So that will the reaction will complete and we will get the final products. We may have the one or two or three products. So one will be the major and other will be in the minor percentages. So now we are going to discuss in detail that what is each step. So for this discussion, we have taken the example of ethane and reacting with the chlorine. But in this slide, if you just focus on it, so I have given you the three kinds of initiators, that what kind of bonds breaking is happening if we have the different system. The first thing is that obviously if we are talking about alkanes, so there are certain kind of alkanes that could be ethane, methane, or propane, or there could be the other longer chains. So they are converting into the radicals. So if you just look at this one, so here the bond which is breaking is the carbon carbon bond which is breaking, and it is through the fish hook arrow. So fish hook arrow, I have already told you that when we draw a half arrow, so this is called fish hook arrow, and this is to show that this reaction is happening through homolytic cleavage, right? So the homolytic is basically where uh, the both partner are breaking the bond in a way that they are taking the equal share. So the carbon carbon bond is breaking in a way that both carbon are taking one electron from this bonded um, electron pair, right? So this is the methyl radical and this is the methyl radical, and we have provided the heat for that reaction. So here, another factor which we need to focus is the enthalpy of the system. So what is the reaction? So if there is a plus sign and there is a certain amount of energy, so the plus sign is showing that this energy has consumed from the system, and this reaction is endothermic. So wherever you are initiating and there is a bond breaking, so you should know that this is the endothermic reaction, right? Because this is some kind of a reaction where the entropy is on its max, and the system is not at the lower pace, and they don't have to adjust at the normal or the lower heat, because they are towards the distraction. So distraction always involves a higher amount of energy, right? So there, the methyl radical and methyl radical is producing by the breaking the bond between the CH3, which was ethane initially, and the 376 kilojoule per mole, or which is the 90 plus kilocalories per mole, is the amount of energy which it require to break the carbon and hydrogen carbon bond. Now the second is which step is in a chain initiation step, and the bond breaking which is involved, right? So chain initiation involve the formation of radicals from non-radical species, right? So the chlorine, Cl2 was a radical non-charged species. It is converting into the Cl radical and Cl radical by breaking that bond again. And if you just look at this one, this is again with the plus sign. So plus sign means this is consuming that amount of energy, and this is the endothermic. So I can write it again. So if someone is just not understanding, so it would be easier for you to understand that this is the endothermic, that this is taking up the energy, right? It is not releasing. So this is consuming the energy. So this reaction is endothermic. Sorry if I'm just going with the, because this is a stylo, so I have to use okay, endothermic reaction, right? So now another kind of bond breaking or the radical formation species are the peroxides. And the peroxides are available in our biological system, and they do break in a form that they are creating some kind of peroxide radicals, right? And here, this is an example where the dibenzoyl peroxide. So peroxide is a species where there is R double OR. So that is a general formula. So now this R is basically the benzoyl, and this is the benzoyl. So here the benzoyl radical are formed. And again, this is the bond breaking step. So this is the endothermic reaction. So why to quote this example, though this is not the part of our example which we are going to discuss today. This is basically to give you the applied side of this reaction, that in our biological system, when we talk about the antioxidants, that they stop the free radical mechanism, which is toxic to our biological system, because once that radical has formed, so this is a chain reaction, this initiated, and it's not stopping easily. So this is just in a chain, and it keeps on it keep on working until the number of all of the radicals are consumed. So that's why the antioxidants are called as the radical scavengers, that they are stopping and they are reducing the free radical mechanism or makeup or body strong enough that it is not going to the free radical mechanism. And lot of other industrial applications where is the production of polymer, they also involve the free radical mechanism or free radical reactions. So next is the chain initiation, the step one, which we have to take into account for our this discussion's example, and that is the ethane reaction with the chlorine one. So the first thing is, if we keep the ethane and we provide the energy or heat, so this is not as labile as the chlorine molecule is there, right? So the chlorine is more sensitive or more vulnerable for the heat and light to break into the radical one. So once this convert into the radical, then it will instigate the alkane to convert into the radical. And we will see in the next steps that how it is instigating the alkane to convert from the neutral molecule to the free radical. So the first thing which is happening, and the initiator is the chlorine molecule, and if you are provided with any other halogen, so that could be the bromine. So you should know that the halogen is the first thing which will convert into the radical form. So here we have applied either the heat or the light. So this is again breaking through the homolytic cleavage, and this is generally called as homolysis, or some pronounce it as homolysis. So this is the Cl radical, and this is Cl radical. Now, one thing I want to mention, that if you have taken the 160 course, which is the introduction of organic chemistry, so you're familiar with the Lewis structure. When we are talking about the mechanism, we do draw the Lewis structure. So Lewis structure is basically a kind of more detailed open structure. So this includes the all of the valence electrons, bonded and non-bonded. So here, if you just look at this chlorine molecule, so the every atom, we know they are in a desire to complete their octet one. So here the chlorine belongs to the halogen class, and they have in their outermost shell the 7 electrons. Now the eighth one is coming by the bonding, sharing with another chlorine atom, or maybe the carbon, or maybe the hydrogen one. So they complete their octet one, and now they are the 8 outermost electron in the outermost, or the valence electron, valence shell. So Lewis, in Lewis structure, we show all of the valence electrons, either they are bonded or non-bonded. So here in chlorine example, there is only the one pair is bonded, and the rest of these 3 electron pairs are the non-bonded, because they are their lone pairs. They already available with the chlorine, right? So here you can see this is a Cl radical, and this is the Cl radical. Now the next step is this one, which is called the chain propagation. So chain propagation, as I told you, that once the initiator has converted into a reactive species, now this is instigating the other neutral molecule to convert into another reactive species. So this is just like if there is a discussion between the people and this agreement, so one is who is bullying or instigating someone to fight or to start a non-stop discussion. So this keep on going, right? So there is must be a one person to instigate and to mess with the rest of the people. So this Korean guy is basically responsible, and that is a culprit to instigate the alkane to break a bond, because now the carbon and chlorine electronegativity difference is basically attracting carbon to break the bond with the hydrogen, and to get or make the bonding with the chlorine, because there it a more attraction for the chlorine, because chlorine is highly electronegative as compared to the hydrogen one. So the step 2, this hydrogen is breaking its bond with the carbon, and again this breaking bond breaking is through the homolytic cleavage. They both are taking the equal share. So hydrogen with 1 electron is making a bond with the chlorine, so it can fulfill its octet and complete its 2 electrons in its outermost shell to acquire the helium electronic configuration. So here this is HCl, and there this is the ethyl radical. Now, as we know, in our system we already have another reactive species, which is ethyl radical. So this will instigate another chlorine molecule, and it will convert it into the Cl radical. So this cycle will keep going. So this step 2 and 3 are continuously running in a cycle. So the number of times a cycle of chain propagation steps repeats is called the chain length. So a reaction could be of few to many thousand chain lengths, depending on the concentration of the reactants of the species and the relative rate of the reaction. So how fast it is going. So just like a fission reaction, but this is not actually the fission reaction, but this is a kind of that it is keep on going. So the one initiator has started this chain, and it will keep going until all of the neutral species are converted into the radical, and then all of the radicals are consumed into the neutral and final products. So now the third step is the chain termination. So once all of the radicals are formed, and obviously they will look upon the suitable partner to convert into the stable molecule with all of their atoms to acquire their octet complete, right? So a step in a chain reaction that involves destruction of reactive intermediates is basically the chain termination reaction. So if we just look at this one, so in our particular example where we have the ethane, we have treated it with the chlorine, and what kind of radicals we formed was the Cl radical. We have the ethyl radical, right? So what are the possibilities? What are the opportunities, or what are the possible products we can form with the radicals? Because there is still open opportunities for all of the radicals that they what they want to um, make the bond. So here the first is that the ethyl radical is again choosing another ethyl radical to make a bond, and then we will have the butane. Another option or opportunity is this one, that this ethyl radical is combining with a Cl radical, and we have the ethyl chloride or 1-chloroethane, which was our main product. And the second thing is that this radical is chlorine radical is again combining with another chlorine, and this is converting into the Cl2, right? So the purpose of this one is that the question could be that how we know what is forming and what is not. So basically these are depending on the chances, the opportunities, and what it is getting through. So for example, if we are controlled the ethane concentration and we have higher amount of the Cl, so obviously how many ethane radical were formed? So that ethyl radical has reacted with Cl radical and with the ethyl radical, so they have formed the neutral one. So whatever the left over, so they will choose whatever is available for that, and they will make the bond with that one to complete that one. Because the important thing is this one, that here the carbon is deficient with the one electron to complete its octet one. And again, the similar case is with the Cl. So obviously this is very much interested and very much frustrated to complete its octet one. So they both will combine and they will attain the most stable form, and to so to satisfy themselves that okay, now they are okay, and they are settled, they have completed their octet one. So in the first three steps, these are basically the coupling of radical to form a new covalent bond. If you just see, these are the two radicals, these are the two radicals, and these are the two radicals which are coupling. Coupling means they are combining and they are forming the new covalent bonds. But if you just look at this fourth kind of opportunity or fourth type of radical termination, so this is called the disproportionation. So disproportionation are the kind of reactions which involve transfer of a hydrogen atom from the beta position. So what is the beta position? Whatever the main carbon is, so this is the alpha carbon and this is the beta carbon. The next to the alpha carbon is the beta carbon, and there is a transfer of that hydrogen to converts them into the more stable um, form. So there is another possibility that it is not going to the normal coupling and to generate the butane. Rather they choose and they opt the formation, the disproportionation reaction, that this is replacing and this is giving that hydrogen to that ethyl radical, that okay, you can just release as a ethane, and I want it to be like an alkene. So what is happening that this radical carbon, because when that bond will broken, so through the homolytic level, again this will be the CH2 radical, and this hydrogen has eliminated as a H dot or H radical. So that has combined with this one, so we get the ethane, plus there's a CH2 and CH2, and that has formed because this is the pi bond which is formed by the combination of these two electrons from both of these carbons. So that was a chain termination reaction. Now, in the last slide of this topic, this is the energetics of the chain propagation steps, because this is the energetics are also very important for the chain propagation reactions, because by these we can estimate and we can tell about the reaction type and the overall reaction type, either this is exothermic or this is the endothermic. Now that depends on the total sum of the energies, whatever have utilized and whatever has released. So one established thing is this one, that whenever there was the bond breaking, so they were the endothermic reaction, and when there is a bond formation, so they are the exothermic reaction. Now we have to see that what was the amount of energy released and what was the amount of energy consumed. So by summing all these steps, so we will get the overall reaction and the total energy, which will give us the information about that overall enthalpy of that reaction. So either overall this reaction is exothermic or the endothermic one. So now the basically the energy decision or the energetics are calculated on the basis of the second and the third step, because the first step was just the initiation, and there was the bond. First thing we initiated by supplying the heat and energy, and then that free radical has formed, and now this is a chain reaction which is initiating, which is propagating. So the energy decisive points or the steps are the step 2 and the step 3, right? So here you can see that when the carbon and hydrogen bond has broken, so this requires plus 422 kilojoules per mole. Now when it has and obviously by breaking that bond, it has converted into the ethyl radical, and this hydrogen has made the bond with the chlorine, and that bond which is formed is the is releasing the amount minus 431. Now for your information is this one, that you can get easily the information about these figures of the energy, that what is the amount of energy released or consumed by from any of the organic chemistry book, or you can just google that one, and there are the appendices at the end of the books, chemistry books, where this is mentioned that the HBr bond utilize that energy or release that energy. So the only thing you have to do is, if you are just getting the information about the H and Cl bond breaking, so you just have to check the sign of that energy, because if it is the bond breaking, they are quoting the bond breaking energy, so it means it is with the plus sign. And if you need that data for your information, that you want to see that what is the amount of energy for bond breaking between the H and Br or H and Cl, so you can use the same digit, the same figure, the amount is same for breaking and for releasing. So obviously for the stabilized bond formation, the equal amount is releasing, and for breaking that bond, so that amount of energy we have to provide to that system. So here this is the bond formation. So definitely when there is a bond formation, when there is a stable molecule, so they have to lose their excited state and they have to settle at a ground state and certain level, so they release energy during the bond formation. So that's why this is with the minus sign, that this is liberating the energy. So now for this step, if you just calculate that one, so plus 422 minus 4331. So what would the balance amount is? Minus 9 kilojoules per mole. And if you are reporting in the kilocalories per mole, so you will calculate accordingly. But right now we have mentioned the plus 422 and minus 431 in the form of kilojoules per mole. Now, for the third step, what was that is the ethyl radical, and there is the Cl-Cl bond which is going to break, and that will convert into the Cl radical, right? So that bond require plus 247 kilojoules per mole to break that bond. And when the bond has formed between the carbon and Cl, so that is the 355 kilojoules per mole, which is liberated, which has released. So that is with the minus sign. And again, if you solve that one, so the overall value is minus 108, right? So now for the overall equation and for the net energy of this reaction, what we do is, and we will sum this one, and we will just cancel the similar species on the both sides of the reaction. So let me do with the pen, and that will be easier for you. So for example, this Cl is on this side of the equation, and this is also available on this side. So obviously on the both side, if we will just shift to that one, so with the plus and minus sign, they will cancel with each other. It's the basic mathematical uh, way to adjust on the both side of the equation. So here another common thing which we are able to find on the both sides of the equation is the ethyl radical. So the pen is 0. Okay. Ethyl radical, right? And what is not able to cancel is there. Okay. So now we will write is the ethane is there, right? Then this is a ClCl, and there is the ethyl chloride, and there is a HCl. And now again, we are just adding this one to get the total, and this is the minus 117. So from this, what you infer, that when the alkane or the ethane has reacted with the Cl2 in the presence of heat or the light, so it has converted into the ethyl chloride, and it has produced HCl in the system, and it has released the 117 energy kilojoules per mole. So it means overall the reaction is the exothermic, right? Because the overall the net energy we resume, because the higher the amount, whatever the amount has consumed, energy has consumed, so there was the amount of energy which has released too. So the overall, what you will feel is that if you are conducting this reaction in any of your glassware, so definitely if you are doing this in any of the round, sorry, this round has turned to be some of critical form. Okay, so if you are conducting this reaction in a round bottom flask, what will happen that you can, if you touch the glass, so you will feel the warmth. So it means the energy is releasing in the surroundings. So this is releasing the energy, so it means you will feel some of the warmth in the reaction flask. So this is the exothermic reactions. Overall the reaction is exothermic. So that was about the radical chain mechanism steps, and you have seen that what are the different steps an alkane is going through when it is reacting with the halogen. So now at the end, there is a task for you. So you have to write a pair of chain propagation steps for the radical bromination of propane to give one bromopropane, and calculate delta H as we did for the ethyl ethane reacting with the chlorine, and it has produced the 1-chloroethane, right? And now I have given you the example that what you have to do is, so let me give you the hint. So that is, though it's not tough, but to make it a little more easier for you is that this is your starting material. This is the propane, right? And you have to treat it with the Br molecule, and produce you have to produce the propane 1 bromo propane with that one. So here's a CH3 CH. This is the CH2, and this is the CH2 and Br, right? So this you have to produce, and obviously you are utilizing Br2 here, and you are using either light or either heat. So what you will do is that you will consult the literature. Maybe you use the same textbook I have referred to you as Organic Chemistry by Brown and Foote, or you can use the Organic Chemistry by Wade or any of your favorite organic chemistry book, and you can just check out the appendices and where the energetics or the energies or the bond association energies have provided for the different bonds. So you can just utilize your science to check either you are writing it for the bond formation or for the bond breaking, and then you will calculate the overall enthalpy for the second and third step. So the first step would be there is a bromine which is producing as the initiator, right? And then you have to go for in the similar pattern what we have followed in the second step and third step for the chlorination of the ethane one. So that task you have to submit on a Moodle, and the other chemistry lovers and the students, they can just comment on that video, and you can share your answer, or you can just DM. So I would be happy to answer you. Okay, have a good day. Thank you.